In exercise 14.2a, they give you the name of an ether, and then they want you to draw it. So whenever you have a name and you're going to the structure, always start with the backbone. And the backbone is going to be after the last YL. Usually if you have a branch, especially if it's a hydrocarbon branch, it ends in YL. And so the last time you see a YL is the last branch. Everything after that is the backbone. So here, the prefix we're dealing with is bute, and that means that this is going to be a four-membered ring, a four-membered chain. We have all single bonds because AN, and it's only hydrogen and carbon we have to worry about. All single bonds, only hydrogen and carbon we have to worry about because the suffix is E. One thing that might make this maybe a little tricky is you've got that cyclo there, and remember that means you're going in a ring. So this is going to be a ring with 4 carbons. What does a 4-carbon ring look like? It looks like a box, a square. So that's a cyclobute, all single bonds, AN, only hydrogen and carbon, E. That is cyclobutane. So that's our backbone. Now we're drawing the molecule, so we could draw it however we want. We can number it however we want. I'm going to number it, and actually let me make this a little bigger. I'm going to number it from, with let's say 1 down here, and then just go around like that. So 1, 2, 3, and 4. All right, well, I have 2 dimethyl groups here. Meth is a prefix for just 1 carbon, so these branches are just going to have 1 carbon each, and we know they're branches because they have that YL. So that's 1 methyl group, that's a 2nd methyl group. They're both coming off of carbon number 1 because it's 1, 1. Then off of carbon number 2, we're going to have an F-oxy group. Now the oxy is telling you that you have an oxygen, and the F is telling you that you have, on the other side of that oxygen, 2 carbons. So that ethoxy group is going to be connected to carbon 2, connected with a bond right here. But we have a chiral center. And this right here is going to be a chiral center because the 4 things bonded to it are different. Going down, we have the 2 methyl groups. To the left, we have the ring without the methyl groups. We have this ethoxy group, and then the 4th thing is an invisible hydrogen. So that is a chiral center, and we need to make sure that this is R. So let's write out our 4 different groups here. We have our hydrogen, we have the oxygen, and let's assign the priorities to them. Now, oxygen has an atomic number of 8, and so that's the highest, because we have oxygen, here we have carbon, and hydrogen. So the atomic number here is 8, this is carbon, so the atomic number is 6, and for hydrogen the atomic number is 1. You can see that the atomic number for oxygen is the biggest, so it's going to have the highest priority. That's going to get number 1. Hydrogen has an atomic number of 1, so it's the lowest, and that's going to get a priority of 4. And now we have these 2 carbons with their tying 6s. Anytime you have atoms that tie, you make a little table. This carbon at the bottom is bonded to a carbon, and another carbon, so that's 3 carbons in that table. The carbon at the top, this one over here, that is bonded to this one right here. That's bonded to a carbon and 2 hydrogens. So carbon, and 2 hydrogens. Okay, let me just clean this up a little bit. And so now you can see when you have these tables, you just look 1 row at a time. Only if a row ties would you go to the 2nd row. The top row for each of the tables is carbon, so those tie. Go to the 2nd row. At the bottom one, it's a carbon, On the top one, it's a hydrogen. Carbon has a higher atomic number, 6 rather than 1, and so this is going to be more important. So this will be 2, and this will be 3. Okay. Okay, so now let's, we need to make sure that this bond is going to give us an R configuration, however we draw this. This bond from carbon 2 to the oxygen. Should we draw it as a wedge, solid wedge, or as a dash? Well, let's try both ways, and whichever one gives us the right one is the one we'll keep. Let's say it goes towards us. That means that the hydrogen would have to be going away. Okay? In that case, we would go from 1 to 2 to 3. That's clockwise, and clockwise is R. And so that bond should be going towards us. Now that was just coincidence that I happened to get that on the first try. Let's say we had done it the other way. If we had done, if we had tried out this first, we would have gone 1 to 2 to 3. So that would have looked like it would have been clockwise, so R, but the fourth thing would have been coming out, so we would have switched it. And that is not what we want. We don't want S. So we would have erased that trial and switched the configurations. So once you get to the point where you have all the priorities, just try each stereochemistry. So for example, this one we tried it with the ethoxy group coming out at us. When we did that, we went from 1 to 2, 3. We got an R. We saw that 4 was pointing away. And so that gave us the R that we needed in this molecule. So that's the right arrangement for this. If these R and S configurations seem a little confusing, you might look back at a couple of the videos for the other problems. D, for example, we went over it, and also in B, we went over it a little bit. And the rules are these. The CIP rules, the Cahn-Ingold-Prelog rules, it's named after the 3 scientists who came up with them, are right here if you want to pause the video and read this for a second. Alright, so that is the correct drawing for this beautiful molecule. We can erase all of this extraneous stuff. We're just left with the molecule.